You ever wonder how your favorite streaming service just knows what movie you want to watch next? Or how a shopping site can show you something you suddenly realize you absolutely need? Well, it's not magic. Not really. It's data. And today, we're going to pull back the curtain on the hidden logic that powers so much of our digital world.
All right, so here's the game plan. We're going to start with the real detective work, how to find these surprising connections hidden in huge piles of data. Then we'll get into how we can prove those connections are actually meaningful. From there, we'll jump into the engines that build personal recommendations, and we'll finish up by looking at how the smartest systems today are mixing everything together for some seriously impressive results.
So first things first, let's talk about the core idea here, the power of association. This is all about finding the invisible threads that tie seemingly random things together. It's really the art of spotting a pattern where everyone else just sees a bunch of noise.
Okay, this all kind of started with this legendary, maybe even mythical story from the world of retail. The tale goes that a supermarket, digging through its sales data, found this really weird pattern. Turns out, on Friday nights, guys who were buying diapers were also very likely to grab a six-pack of beer. Now, whether that's totally true or not, it perfectly sets the stage for what we're talking about, finding a hidden connection that you can actually act on, like, moving the beer aisle right next to the diapers.
Now, we take these discoveries and we formalize them into what we call association rules. You can just think of them as simple if-then statements. If a customer buys X, they're probably going to buy Y. This whole thing started with what they called market basket analysis in grocery stores, but you can see how this logic applies to basically everything, from the news articles you read to the songs you add to a playlist.
The whole goal here is to find what data scientists call frequent item sets. And that's just a fancy way of saying a group of things, like our diapers and beer, that show up together a lot. But what exactly is a lot? And how do we really know if a pattern is a genuine insight or just, a random coincidence? To figure that out, we need some better tools.
And this is where we get into the metrics. These are the tools that let us measure the strength of a potential rule. It's how we separate a really valuable piece of information from what's basically just static.
Our first metric is called support. And honestly, this one's the most straightforward of the bunch. It just measures how often a set of items appears in all of the transactions. So if bread milk shows up in 200 out of 1,000 shopping trips, its support is 20%. It's just a basic measure of popularity. A rule with really low support might not be that useful, even if it's kind of interesting.
Next up, we've got confidence. This metric gets us a lot closer to that if-then idea we talked about. Confidence basically asks, of all the times someone bought item X, what percentage of the time did they also buy item Y? So let's say 100 people bought bread, and 80 of those people also grabbed some milk. Well, the confidence of the rule, bread leads to milk, would be a pretty solid 80%. And here's the math behind it. The formula for confidence is really just a simple but powerful ratio. You take the popularity of both items showing up together, and you divide it by the popularity of just the first item. It's a direct answer to the question, okay, given that X happened, what are the odds that Y also happened?
But here's the thing. High confidence can sometimes be a little misleading. I mean, what if milk is just super popular and almost everyone buys it anyway? Then its appearance with bread might just be a coincidence. And that's where our third metric, lift, comes in. Lift tells us how much more likely someone is to buy Y when they buy X compared to just the normal chance of them buying Y. A lift value that's greater than 1 tells you there's a real relationship there.
What the lift formula does is actually pretty clever. It compares how often two things happen together versus how often you'd expect them to happen together just by pure chance. So, by dividing the support of them together by the product of their individual supports, we can see if the connection is real or just a fluke. A lift over 1 means we are definitely onto something. So just to recap, support tells us if it's popular, confidence tells us how predictable it is, and lift tells us if it's actually interesting.
So how on earth do you find these rules in data sets with millions of transactions? You can't possibly check every single combination. Well, we use this really smart process called the a priori algorithm. It works step by step. It starts small, finding individual items that are frequent. Then it uses those to build pairs. It throws out any pairs that aren't popular enough. And then it uses the pairs that are left to build triplets, and so on. It's a super efficient way to pan for gold without having to sift through all the dirt.
For those of you who want to peek under the hood, this pseudocode here really shows you the heart of the a priori algorithm. You can see it's a simple cycle of generate and test. First, it generates potential item sets that could be frequent, and then it scans the data to see if they actually make the cut. It's this efficient, iterative logic that makes it such a foundational algorithm in data mining.
Okay, so association rules are fantastic for finding patterns across a whole population. But what happens when we want to get personal? How do we go from people who buy X also tend to buy Y to, hey, you might really like Z? Well, that's when we step into the world of recommendation engines.
Now, recommendation systems aren't a one-size-fits-all kind of deal. They actually come in a few different flavors, and each one has its own strategy for figuring out what you might want to see next. The big ones are collaborative, content-based, knowledge-based, and then hybrid systems, which, as you can probably guess, mix and match.
So let's pop the hood and take a closer look at how these different engines actually work. First up is collaborative filtering. This is the engine that powers all those customers who bought this also bought suggestions. The idea behind it is super simple but incredibly powerful. It basically finds other users who have similar tastes to you. So if you and some other person have both rated the same 10 movies highly, the system figures you'll probably also like other movies that they loved but you just haven't seen yet. It's the wisdom of the crowd.
The second big approach is content-based recommendation. This is the because you watched model. Now, instead of looking at other people, this system looks at the items themselves. It builds a profile of your tastes based on the features of things you've already liked. The genre, the director, the actors. Then it just goes out and finds other items that have similar features. Now, each of these has some pretty clear trade-offs. Collaborative filtering is amazing because it can help you discover something totally unexpected by tapping into the tastes of others. But its big weakness? It needs a lot of data to get started, which is a huge problem for new users or new items. That's the cold start problem. On the other hand, content-based systems don't have that issue, but they can easily trap you in a filter bubble where you just get shown more and more of the same stuff you already like.
And then there's a third type, which is a little different. Knowledge-based systems. You see these a lot for big, complex purchases. Instead of trying to guess what you like from your past behavior, they just ask you what you need. Think about a car website that asks for your price range, how many seats you need, and what kind of fuel economy you're looking for. It's less about predicting your taste and more about satisfying your specific requirements.
Okay, so if each of these methods has its own obvious pros and cons, the next logical question is, why not just combine them? And that's exactly what the most advanced state-of-the-art recommendation systems are doing today. They're all hybrids.
One way to build a hybrid is with what's called a monolithic design. Now, instead of just running separate engines and blending the results, this approach builds one single, massive algorithm from the ground up, weaving in all the different strategies and data sources from the very beginning.
But that monolithic design is not the only way to do it. You can also run different recommenders in parallel, side by side, and then just blend their results together. Or you could create a pipeline, kind of like an assembly line, where one system's output becomes the input for the next one, refining the suggestions at every step. So, from finding hidden patterns on a supermarket shelf to predicting the next song you're going to fall in love with, these systems are powerful tools that are quietly shaping our digital lives, making our choices easier and, well, more relevant. But as they get smarter and smarter, it does leave us with one final thought. In a world of perfect predictions, how do we make sure there's still room for serendipity, for that amazing, joyful experience of discovering something we never ever would have looked for on our own?